Hi everyone, welcome to Scientific Grounding Week 7, Artificial Intelligence and Learning, Introduction to Hybrid Intelligence. I am Dr. Andy Nguyen, a Research Council of Finland postdoctoral research fellow working at Learning and Education Technology, LET Research Lab, Faculty of Education and Psychology. At the same time, I am also holding the title of Docent, aka Adjunct Professor, in Applied Artificial Intelligence, AI, at Faculty of Information Technology and Electrical Engineering, ITE. In today's lecture, first I will introduce the learning objectives of the lecture, then provide a definition of hybrid intelligence before I'll discuss the theoretical grounding on human learning, and AI machine learning at the core of hybrid intelligence. After that, I'll discuss about AI and hybrid intelligence in the specific context of education. Last but not least, I'll go through the ethics and privacy for AI in education. Finally, I'll summarize the key takeaways for today's lecture and concluding with relevant readings and assignment. After today's lecture, you are expected to familiarize yourself with the core principles and terminologies related to hybrid intelligence in education, including concepts and theories in both learning sciences and artificial intelligence. You will also understand how human learning intersects with AI machine learning to create unique teaching and learning environments. And lastly, you will also get to understand the ethical dilemmas and responsibilities that arise when implementing AI, or hybrid intelligence in education. So, you might be wondering, what is hybrid intelligence? This is a relatively new concept in the last decade. The concept is still evolving over time. Nevertheless, one definition for it could be from Delleman et al., 2019, that hybrid intelligence refers to the ability to accomplish complex goals by combining human and artificial intelligence to collectively achieve superior results, and continuously improve by learning from each other. If you are getting confusing about what is artificial intelligence, how it relates to human learning, what it means by human and AI learning together, don't worry about it for now. During this lecture, I'll step-by-step walk you through the basic terminology of AI and how it works before revisiting this concept of hybrid intelligence. Yet, before we are even moving to AI and machine learning, I would like you to first think about, what is learning? We are learning throughout our lives, but what does it exactly mean by learning? Please think about this for a few seconds.
The concept of learning has been a focal point of study across various disciplines including psychology, education, and cognitive science. While it is widely acknowledged that learning is a complex and multifaceted process, its definition often varies depending on the theoretical framework under consideration. Since some of you might not have previous background in learning sciences or cognitive psychology, I'll now walk you through some of the key learning theories showing main perspectives on learning. For those of you who already have prior knowledge on this topic, this will be a recall session to refresh your understanding on human learning. But please note that, due to the limited time of the lesson, I will not cover every theories but only some of them. And also, as it is not the main focus of the lesson, I will not go into too much details within each theory. Nevertheless, if you are interested, you are welcome to explore and read more about them. First, one of the earliest and most popular learning theories is behaviorism. The term behaviorism refers to the belief that behaviors can be measured, trained, and changed. Also known as behavior psychology, behaviorism is a theory of learning based on the idea that all behaviors are acquired through conditioning. Conditioning therefore occurs through interaction with the environment, which then makes behaviorists believe that our responses to environmental stimuli shape our behaviors. Watson in 1926 stated that, "Give me a dozen healthy infants, well-formed, and my own specified world to bring them up in, and I'll guarantee to take anyone at random and train him to become any type of specialist I might select: doctor, lawyer, artist, merchant chief and, yes, even beggarman and thief, regardless of his talents, penchants, tendencies, abilities, vocations, and race of his ancestors. I'm going beyond my facts, And I admit it, but so have the advocates of the contrary, and they have been doing it for many thousands of years. This statement reflected how behaviorists believe in learning, and how we can teach students to learn. From this perspective of behaviorism, learning can be defined as a relatively permanent change in behavior that occurs as a result of experience. Related to behaviorism, the concept of connectionism and classical conditioning were introduced. Connectionism describes learning as a process of trial and error, with reinforcement when the correct response is demonstrated. The law of exercise states that repetition strengthens the connection between a stimulus and a response. The law of effect states that a rewarding response that follows a specific stimulus is more likely to be repeated than an unsatisfying response. Classical conditioning looks at how reinforcement, experimental extinction, and generalization affect learning. Operant conditioning looks at manipulating variable in an effort to identify, predict, and control behavior. The classical conditioning is demonstrated by a very well-known experiment by Pavlov. He rings a bell in front of a dog every time he gave food to the dog. He repeats that many times to establish the dog's connections between bell ringing and getting food. After a while, when the bell ringing, it acts as an antecedent triggering the conditioned response from the dog as the dog is expecting food to come. Another well-known learning theory is cognitive development by Piaget. Piaget's theory emphasizes the active role of the learner in constructing their own understanding, aligning closely with constructivist philosophies of learning. Piaget postulated that cognitive development occurs in a series of stages, each characterized by qualitatively different cognitive abilities. The four main stages in Piaget's model are:
Sensoromotor stage, 0 to 2 years. During this stage, infants acquire knowledge through sensory experiences and manipulation of objects. Key milestones include the development of object permanence, the understanding that objects continue to exist even when they are out of sight. Pre-operational stage, 2 to 7 years. In this stage, children begin to engage in symbolic play and learn to manipulate symbols, such as words and numbers. However, their thinking is still egocentric and not fully logical. They struggle with tasks that require understanding the perspectives of others or the concept of conservation, example, understanding that quantity remains the same despite changes in shape. Concrete operational stage, 7 to 11 years. This stage is marked by a significant increase in logic and the ability to perform operations on concrete objects. Children begin to understand the principle of conservation and can perform tasks that involve classification and seriation. However, their reasoning is limited to concrete, tangible situations and objects. Formal operational stage, 11 years and above. During this final stage, individuals become capable of abstract and hypothetical thinking. They can reason systematically, think about possibilities, and engage in deductive reasoning.
Piaget's theory has established the foundations for many later learning theories. And importantly, Piaget's theory has been widely applied in early childhood education. Moving to the next learning theory, Vygotsky proposed sociocultural theory that also provided the foundation for many later theories, including self-regulation, self-regulated learning, and socially shared regulation in learning. A few key points proposed by sociocultural theory are that social interactions are essential. Beyond looking at one's behavior, their interactions with the environment are important and embedded in their learning.
Self-regulation is developed through internalization. Human development occurs by tools, language is most important one.
Although I'm not able to cover in this lecture, you are encouraged to search and read about zone of proximal development, what can I do with others, what I can do alone.
Another common perspective to look at learning is grounded by information processing theory. Human are processors of information, attention controls encoding of information, storage of knowledge as also retrieval in different memory layers. All concepts related to this perspective involve research on eye movement, recall, recognition, attention, interference of perception and memory, problem solving, visual and auditory perception, short and long-term memory. An example could be referred to Memory 2 Store model by Atkinson and Schifrin 1968.
Furthermore, from an organizational perspective, learning could be explained by a double loop between feedback and action, and between those with the mental model. Double-loop learning in organizations is a concept proposed by Argyris 1977 and has been applied in several organizational contexts. Hope these gave you some ideas about how learning is perceived from different perspectives. Although there are differences in which perspective we look at learning, learning can be broadly described as a process through which individuals acquire or modify knowledge, skills, behaviors, or attitudes, facilitated by experience, study, or teaching. We have now understood human learning. Then what is artificial intelligence machine learning and how it works? These days, you may hear or read a lot about those terms AI, machine learning, deep learning as such. What are the differences between them? We will look at this now. AI exists everywhere surrounding us these days with or without you knowing of. For instance, digital personal assistants like Siri, Alexa, Cortana, or Google Now, or Google Search and Google Translation, they all use AI algorithms at the back. If you are an online shopping fan, you may get different product recommendations. Those are recommended by AI as well. If you are using a smartphone, I wonder if you are using Face ID to unlock your phone. Face ID is also an example of AI application. And recently, smart houses or smart cars with AI are getting more and more popular as well. So, what is AI? AI could be defined as intelligence demonstrated by machines and computer programs. It can appear in different forms of tools, software, robots, or analytic models. You may still find it confusing, so let's put it in a simple term. AI means program or technology trying to mimic human behavior, such as replicate the way human thinks, learns, or responds to the environment. You may have heard about the other terms like machine learning and deep learning as well. They seem to be very similar to AI, so what are the differences between these concepts?
Basically, a machine learning is a subset of AI that have an ability to learn without being explicitly programmed. Machine learning studies focus on algorithms and statistical models that automatically enable machines to improve their performance, or you can say that the machine can learn and regulate itself. An AI deep learning is a subset of machine learning that applied artificial neural networks to learn from vast amounts of data.
There are also different branches of research and terminology related to AI technology. As by definition, AI are applications trying to mimic human behavior. The development of AI focuses on different aspects such as how we speak, through natural language processing, NLP, or how we see the world, through computer vision research. Going back to AI machine learning, AI also tries to mimic how humans learn from an information processing perspective. And also similar to connectionism and conditioning in human learning, AI learn from training the model from input. The model is evaluated and validated before using in applications. Then the data will be fed back to improve the model in the model feedback loop. This slide demonstrates an example of machine learning in the context of an educational game, where gameplay data was used as input to train AI models to make predictions, and those will be utilized to create adaptive materials within the game environment. Now, after you have some basic understanding about what are AI or AI machine learning, let's discuss about why do we need AI in education. You may have heard about ChatGPT, a generative AI application that utilizes AI large language model, LLM. Here is the result when I asked ChatGPT to write me an essay about why do we need AI in education. Impressive, I. And what's even more impressive is that AI provides this output within a few seconds. Whereas, It may take me at least more than 5 or 10 minutes to write something similar. This also clearly shows the potential impact of AI on education, especially in learning. While there has been a surge of discussion on AI in education since the public release of ChatGPT on November 30, 2022, AI in education is not a new concept in research. Indeed, there have been decades of research on AI in education. For instance, even way before ChatGPT release, Intel has stated that artificial intelligence is enabling educators to bring personalized learning to the classroom and empowering students to learn the best way they can. What it means by that? There has been extensive research on different applications of AI in supporting learning and teaching. You could see here a few examples of it: AI in learning analytics, AI algorithms for personalizing learning, for customized learning environments, as an example demonstrated earlier with AI machine learning for educational game environments, AI for automatic curriculum design, which has been partly adopted for the lecture content today, AI for on-time feedback, for detecting or even predicting at-risk students to provide extra support. It's not only at the conceptual level in research only, but there have also been several AI integrated commercial applications, such as Duolingo for language learning, House-based learning management system, Carnegie Learning, or Third Space Learning. So, you have listened to great things about AI. Then should AI replace human teachers soon? Why do we need hybrid intelligence rather than just AI, artificial intelligence? Is it merely an ethical question but not a productivity one? ChatGPT is great, but it's not the ultimate magic, unfortunately. I asked it a common question that I asked everyone every day: how are you today? What I received back, not a common answer from human though. As an AI language model, ChatGPT don't have feelings or emotions. Then, is emotion the only AI doesn't have? If you are afraid that one day you will be replaced by AI, don't have to worry about it. But still, you still have to worry about AI, not AI itself, but people you could use or even collaborate with AI. Why you don't have to worry about being replaced by AI completely?
Examples of uniquely human skills that cannot, or at least unlikely to, be automated in the near future by AI. Contextual reasoning, critical thinking, creativity, emotional intelligence, interpersonal communication, empathy.
Those are the examples of skills AI could not soon surpass us in many ways. Nevertheless, it's too soon to ignore AI. Examples of tasks that AI may perform better than human.
Task-specific automation. Managing repetitive tasks. Process big data.
Search and retrieving information. Discovering patterns. And for these tasks, AI could outperform us as human not by a few percentage but by multiple times in productivity and efficiency. So what should be a good vision for AI with us as human in the future? Human unique needs and goals may not always be aligned with AI systems' decisions, depending on their design and feeding data. It is, therefore, better to use AI as a support than as a replacement for human decision-making. At the same time, human also needs to understand AI and augment AI in the ways that it could best support human. With the bidirectional augmentation, human and AI could collaborate together for hybrid intelligence towards superior problem solving and results. In this course and others, you may have learned about self-regulated learning as an important aspect of human learning. Forward hybrid intelligence. Recently I together with Javella and Hadwin proposed a model for human AI shared regulation in learning. You are encouraged to read more upon this work to have a better understanding of research directions towards human-AI collaboration for hybrid intelligence in the future. Last but not least, we have to be always careful when researching, developing, or implementing AI, especially in education. In October 2019, researchers found that an algorithm used on more than 200 million people in U.S. hospitals to predict which patients would likely need extra medical care heavily favored white patients over black patients. While race itself wasn't a variable used in this algorithm, another variable highly correlated to race was, which was healthcare cost history. The rationale was that cost summarizes how many healthcare needs a particular person has. For various reasons, black patients incurred lower healthcare costs than white patients with the same conditions on average.
Amazon's one of the largest tech giants in the world. And so, it's no surprise that they're heavy users of machine learning and artificial intelligence. In 2015, Amazon realized that their algorithm used for hiring employees was found to be biased against women. The reason for that was because the algorithm was based on the number of resumes submitted over the past 10 years, and since most of the applicants were men, it was trained to favor men over women.
That gives us an example why we always should consult, understand, and apply different ethical principles for AI in education. The ethics consideration should not only pay to the AI algorithms itself but also the data fed into it and policies surrounding the implementation, usage, and even disposal of AI. The key principles for ethics for AI in education is transparency, privacy, accountability, inclusiveness, and security. Key takeaways. Through today's lecture, you have learned about the concept of hybrid intelligence as well as theoretical perspectives on human learning, what it is, AI machine learning. Furthermore, we have discussed that human unique needs and goals may not always be aligned with AI systems' decisions, depending on their design and feeding data. It is, therefore, better to use AI as a support than as a replacement for human decision-making. Ethical and privacy issues should be carefully considered in the research, development, and implementation of hybrid intelligence solutions.